Because exponents and logarithms are related, and we know that there are properties of exponents, there are likewise properties of logarithms. So let's take a look at them. So, if we want to take log base a of 1, the result is 0, because if we rewrite this logarithm as an exponential, we would have the base a raised to the exponent 0, and a to the 0 equals 1. Likewise, if we rewrite log base a of a as an exponent, we would have a to what power is a? A to the first is a. So you'll notice that the right-hand side is the exponent that makes the base become the argument. So, likewise, a to what power is a to the r? A to the r is a to the r. This one may be a little bit odd, but if we look at just the exponent for a moment, log base a of m, what does that mean? Log base a of m is the exponent that makes a become m. Now look at this. We have a to that exponent equals what? Well, this whole thing is the exponent that makes a become m. This one's a little odd, but this is the key to the understanding. In exponentials, whenever we multiply two exponentials that have the same base, we add the exponents. In the same way, if we multiply in the argument, we can add what are essentially the exponents. Remember, this whole logarithm is an exponent that makes a become m. Likewise, this logarithm is an exponent that makes a become n. So if we're multiplying the argument, then we can add the logarithms. And if we're dividing, we can subtract the logarithms. Now notice what we're dividing. We're not dividing two logarithms. We have one logarithm, and we're dividing within the argument. And that yields a difference, a subtraction of the two logarithms. Now, if we have m to the r inside the logarithm, so we're taking log base a of this quantity, we can bring this exponent out. Now this is because essentially what we're doing is we're multiplying exponents. We have an exponent here, and log base a of m, this is itself an exponent. So let's use these properties to help us out. To help us out in this, let's remember what ln means. We have log base e of e to the 5, e to the 5th. Now, notice the base of our logarithm and the argument have the same base. So we have something that looks like this. So log base a of a to the r is what? Remember what this is asking. What exponent makes a become a to the r? And the answer is r. So if we come back to this, what exponent makes e become e to the 5th? 5. Now likewise, notice the exponential and the base of our logarithm match. So this is a raised to the log base a of m, and this is m. So what's this? is going to be 9, because this logarithm is the exponent that makes 5 become 9. So if I put it on 5, it'll make it become 9. Now here we have subtraction of two logarithms that have the same base. So this matches the rule where we have log base A of m over n is log base A of m minus log base A of n. We're going to go this way with it though. And so we have log base 3 of 54 halves. So log base 3 of 27. But now, notice 27 is 3 cubed. So we have log base 3 of 3 cubed. So log base A of A to the r is just r. So what's the answer here? It's just 3.